Hello and welcome to my channel. In this video, I will teach you how to design your photovoltaic panel in AutoCAD. Before starting, let's talk about photovoltaic panel. A solar panel or photovoltaic module is an assembly of photovoltaic cells mounted in a framework for installation. Solar panel or solar module use sunlight as a source of energy and generate direct current electricity. A collection of PV modules is called a string, and a system of panels is an array. Array of photovoltaic system supplies solar electricity to electrical equipment. This is a view of a standard crystalline PV panels with 60 cells. In this tutorial, we are going to draw a specific technology of photovoltaic module called half-cell solar panel. Half-cell module have solar cells that are cut in half. This is the cell for standard PV module, and this is the half cells. Traditional 60 and 72 cell panel will have 120 and 144 half cut cell respectively. In this tutorial, we are going to draw in AutoCAD a photovoltaic panel with half cell technology with 120 cells. This is the various properties of the solar panel. This is the various dimension of the cell, the gap between the cell, the gap between the cell and the frame, and also the dimension of the ribbon. This is for the cell dimension. We are going to draw the solar cells with these properties. All the dimensions are in millimeters. This is a front view of the solar panel. This is the back view of the solar panel, and this is the electrical circuit. For the electrical circuit of the half-cell solar panel is composed of 60 cells connected in series with other 60 cells connected also in series. The two connected series cells are connected in parallel to have an output current, which is the assembly of the two cell string. Okay, let's go to the drawing. Okay, after talking about the photovoltaic description, let's go to the drawing of the PV module in AutoCAD. So, in this interface, I drop the different properties of the solar cells and also the different distance between the cells, also the distance between the cells and the frame, and also the properties of the ribbon. Also, I added the electrical circuit to understand the current flow in the PV module. Also, a preview of the PV panel for half-cell PV module. In the first stage, we are going to draw the PV cell like this shape with a chamfer in the two corners. To do that, we are going to select the line command, specify the first point, So if the ortho mode is not activate it. Take your cursor on this side and type the length, which is 156 as a length, and press enter. Take your cursor below and type the length of 78 and press enter. Take your cursor on this side and type the length of 156 and press enter, and press C to close your rectangle. Okay, this is the first solar cells with this dimension. Okay, let's take the measure of the solar cell dimension to make sure about the first dimension. Okay, it's okay. Erase this dimension, and we are going to make a chamfer in this T corner. To do that, select a chamfer command. Select distance to modify the distance, and enter the distance of chamfer in this side and this side. We make, for example, 5 for the first chamfer and press enter, and 5 also for the second chamfer and press enter, and select this side and this side. Okay, press enter to repeat the last command. Select this side and this side. Okay, it's okay now. This is the first stage. We are going now to make the bus bars. In this PV model, we are going to make 5 bus bar solar cells. Okay, to make bus bar, we are going to work with polyline. In order to modify the thickness of the PV of the bus bar, select the polyline. Specify the first point, and we are going also to modify the width of the polyline to make the thickness of the bus bars. Click on width and specify 0.9 as first starting width. Press enter, and 0.9 and press enter. Okay, and we are going to specify in this point, and take your cursor below and type 6 as the gap, and escape as the gap between the cells and the other cells. In order to make the other bus bars, we are going to work with a rectangular array. Select rectangular array, select the object, press enter, and go to the properties of the array and modify different properties of the array. In this form, we are going just to choose 5 columns and just one row. Also, we are going also to modify the distance between the column. So this 5 bus bar must be divided into the solar cells with 156 length. We can make, for example, 30. Press enter. To make the array in the left side, we can make the value as menus value. We added menus and press enter. In order to make the grid lines in these solar cells, we are going to work with hatch. So before, close the array properties and click H and press enter to activate the H. Okay, in H you can select different type of H, for example this one, or gradient H. In order to make the grid line in the solar cells, we are going to choose this type of hedge which resemble for grid line in PV module and close the hedge creation. This is the first stage in the process of creating of the PV module. So after that, we are going to make the other solar cells by array, by the rectangular array also. So after creating the first solar cell, we are going now to create the other cells. Okay, let's take a look on the overview of the PV module. The current flow is from the side. This is the negative and this is the positive side of the PV cells. Okay, the first cell is oriented above and the other line is oriented below. This is the current flow in the PV module. This is the first sense and this is the second sense. Okay, let's draw a PV cell in the other side. To make that, we are going to work with copy command. Select the object, press enter, specify the base point and take the cursor near the PV cells and press enter. Repeat the command, click enter, specify this point and specify other point for paste and escape to finish the command. We are also going to work with rotation or rotate command to make a rotation of the PV cells in the other sense. Select the command, specify the object, click right on the mouse, specify this point and enter the rotation angle of the cell, which is 180, and press enter. We are going to move this part near the other cells. Select move command, select the object, validate with the right command and press in this point, specify this point to move the object, deactivate auto mode and move the cells near the first one and click on. Okay, so we have to make a gap between the two cells. So we are also working with move command. We are also specify the other cell, the second cell. Okay, we make the anterior cell, click right and click on this point and take your cursor in this side, activate the auto mode, take your cursor in this side and type 6 as a gap between the cells and press enter. This line is also moved. We have to remove this line for the first cell. Click on move, select the object, specify this point and move it to its places. Okay, after making these two cells, we are going to make a rectangular array based on these two cells and also on the other properties of the PV module. Okay, so that we are going to click on rectangular array, select the object, click right, and modify for the properties of the array. In this PV module, we are working to create 120 solar cells, 60 solar cells connected in series, and the other connected in series. So that we have two cells. So we have to create just 3 columns based on two cells and 10 rows and press enter. This is 60 cells. We have also to modify the gap between the column and the gap between the rows. For the gap between the columns is about the length of this cell plus the gap plus the length of the other cell plus the gap. It's about 324. Press enter. It's the same for the gap between the row. It's the length of this part, 78, plus the gap between the cells, which is 6. So the result is 84. Press enter. This is the first part of the PV module. We close the array and we are going to make a link between these cells. So the current flow in this PV module is as follow in this sense and in this sense, then in the 3 array, in the 4th array, etc. This is the end. Okay, we are going to make the connection between this cell and this cell. We are also going to work with polyline. Press this point, take your cursor above and type 6, enter. Press copy command, select this line, specify the base point, and specify the other places of this grid line. I'm going to make the same for the other cells. So we just make a copy of this 5 grid line or bus bar, select copy, select this bus lane, and place your cursor into the right places. It's the same for the cells below. We are also going to make this extended of this part. So copy this part for the second time. Select copy command, and in this second step we are going to select this base point, make auto mode off, and select this point. same for the other cells. The same for the other cells. Okay. Now we are going to link this part with this part, working with polyline. Select polyline, and we are also going to change the thickness of the polyline. Select this point and click on width, and we are going to modify the length of the polyline. In the PV module, this stringing interconnection is about 2 millimeters. Give 2 and press enter. 2 another time and press enter. Make auto mode activate and take this part and escape. Press and enter to repeat the last command and select this point and also this point and escape. Press enter to repeat the last command. Select this point and also this point and press escape. The same for the other cells, the cells in below. So this is the first sense of the current. It will come from the sense and go for this part. Select polyline, select this point, and select this point, and escape. Press enter to repeat the last command. Select this point, and select this point, just this point, and escape. And press enter to repeat the last command, and select this point, and this point. This is the output, the first output of the PV module, and this is the second output of the PV module, this one, and escape. So now we are perform the first part of the PV module. The other part of the PV module will be made using the mirror command. Let's select the mirror command. Select the object. Press right, click right, and select the first mirror line. Just 2 points of the line of the mirror. Select this point and this point. You asked to erase source object. Click no. We are now make the PV, the overall PV module. So let's take the measurement of an individual solar cell with measurement line. Select linear measurement. Select this point and this point and move your cursor above. It's okay. Press enter to repeat the last command. Select this point and this point and move your cursor in this side. It's okay. The dimension of these solar cells are okay. Also for the dimension of the gaps, select this point and this point and move your cursor. It's 6 millimeter. Also the gap between column, it's 6 millimeters. We are now go to make the bypass diode. In this module, we have 3 bypass diodes as mentioned in the overall table for the description of this PV module. We are going to make a bypass diode between these 2 lines and these 2 lines and this part. So select polyline, select this point and this point, make auto deactivate off this point, and also select this point and extend the line. Make a copy of this part, select copy command, select this point, and paste here, and also in this part. It's okay now. We are now going to make the frame of the PV module. Select the polyline, select the first point, and we are going another time to change the thickness of the line. And click width and select, for example, 20 millimeters. Press enter. 20 another time and press enter. It's with large thickness. Press escape. Select the polyline for the other side. Specify the first point. Select width and enter 10. Press enter. 10 and press enter. Make auto mode activate. Take your cursor from the side. Specify the second point. Take your cursor below and specify this point. Take your cursor from the side and specify this point and click C to clear your rectangle. So let's take the overall measurement of the PV module. Specify this point and specify this point and move your cursor into the appropriate places. For example, this module is about 1618 millimeters. For the other measurement, select this point and this point and move your measurement above. It's about 9.6 meters. So this is the methodology that you can follow to draw your PV module in AutoCAD. With the various steps, we are going step by step to make your PV module. This is the overall description of the PV module. You can also add some description of the PV module. For example, you can make a table, or you can add the name of the PV module. You can also add various other measurements for your PV module. It's depend on your objective. This is the final drawing for this tutorial. Thank you for your follow.